Brent Regan. My very, very good friend Brent Regan. I don't know if you're watching this live or whether you're watching this on YouTube or watching it at all, but Brent Regan came up with I want to say the Wave Runner. Brent is a brilliant man. He's a brilliant engineer. He designed, well, he didn't design, he manufactured a Lancer 4, which not only was the fastest Lancer at Oshkosh in its year, it also had the best workmanship. Brent Regan's one of my favorite people in the whole wide world. He's one of the great engineers, one of the great minds. Brent Regan is so much smarter than me. It just kind of leaves me like looking out the back window of a station wagon that's pulling away to the special needs house. In any event, Brent Regan asks, "Hey man, what's up with gravity?" And my reply to Brent would be, "Hey Brent, shouldn't you really be saying what's down with gravity?" I think I've answered my question for you, haven't I? I think I've answered the question for you, Brent. What's down with gravity? See, if you were high now, Brent, it'd all make crystal clear sense to you. The fact that it may need a little elaboration is just a function of the fact that your brain's not keyed to really understand the deep, deep, deep meaning of what I'm trying to say when I say it's not what's up with gravity, it's what's down with gravity. With me? Yeah? Okay. Look, what's down with gravity? Here's what I think what's interesting about what's down with gravity is an interesting way to look at things. Gravity's been assumed to be a monopolar. There's no anti-gravity. There's a positive charge to a magnet and positive charge to an electrode, but there's no negative charge to gravity. There's not anti-gravity emitters, at least not in nature. So that's interesting. And gravity appears to operate instantaneously throughout the universe and doesn't seem to be limited by the speed of light, although I'm not really completely clear about that. So gravity is quite odd. But when you get into the large structure of the universe, the megastructure, you find out that the universe is made of gravity. It's made of gravity. It's a good way to think about it. The universe, as it appears in its observable form, is a artifact of gravity interactions. So gravity is, in fact, the molder of the universe. It's the big picture thing. Here's what's interesting about gravity. Newton had an idea that gravity was essentially an invisible thread that tied, let's say, the planets to the sun, and that they went around tied to this thread, and that you could understand planets as sort of Mr. Reitzer gets me with your puns are bad and you should feel bad. And who is that? That's Zoidberg, isn't it, from Futurama? That it was basically could be thought of in a mechanical way, in a mechanical way, and it was considered to be just sort of a connecting force, like I say, like a tether of some kind. Now along comes Einstein with the many out of the park brilliant things. I mean, to be bagging on Al, but when Al starts talking politics, he needs to be bagged on. And the people who put him up there because they agree with his politics need to understand that we don't ask Albert Einstein about fashion tips or about grooming tips, so why should we ask him about political information? He's got as much right to comment on grooming information as political information, but we don't go to him for style tips because he's not qualified to talk about style. So along comes Einstein, and Einstein talks about gravity as being depressions in space-time. And everybody who's followed anything like this knows that you've seen it in every single cheap movie, starting with the Black Hole, the Disney movie. One way to think about gravity is to think about a massive planet as being a heavy object that's on a rubber sheet, and it depresses the sheet down. And that a smaller planet might be like a lighter object on a rubber sheet, and it makes a smaller depression. And if you launch a BB, sure enough, it'll circle around one, and then it'll circle around the bigger one, and as it gets lower, it gets faster, and so on. All of these things are a three-dimensional perspective of what gravity looks like looking down. And I bought this for as long as it's been sold to me, which has been 40 years now. 40 years I've been in astronomy, a little more than 40, 41, 42 years. I've understood it. And I've realized, okay, that's one way to think about gravity, is a depression in space-time, but it's nonsense. It's a bad analogy, and it's a bad analogy. It's better than nothing. Well, let me tell you what's bad about this analogy and why gravity is, down. Not what's up with gravity, what's down with gravity. That analogy doesn't really function because it is saying that it is being that space-time is being pushed into what appears to be the third dimension in the analogy, but which would be the fourth dimension. It gives you the sense of a funnel in that it's like it's a displacement in space. That's it. That gravity is like a displacement, like a funnel in space. It's pushed space. But it's not. The way to think about gravity, I think, in terms of our theories of gravity, is to understand that what gravity is weakened space-time in the vicinity of a large mass. The better way to think about gravity is what happens to mass in space-time that has been thinned by the presence of mass. The texture of space-time inside a gravity well is thinner. If you think about it as less dense rather than as displaced, then you start to get the idea that, okay, things are accelerating towards the mass because the space is thinner. The space-time, not the matrix, the stuff. We think of space as empty because there's no matter in it. Essentially, there's very few particles in there. It's a vacuum. Fair enough. But the actual matrix of space-time, even if there's not a single atom in the space-time, if you have a cubic mile, let's say, and you have a perfect space-time, perfect vacuum of space with not a single hydrogen atom in a cubic mile, let's just say, it's not quite that good, but it's damn near that good. If you had a cubic mile and there wasn't a single hydrogen atom in that mile, we would say that is a perfect vacuum, and that is in fact what three-dimensional space is. But inside that cubic mile, the actual matrix of the mile has a structure, and that structure is what we call space-time. It has a structure, and it has a resistance, because if it didn't, a particle of light couldn't move through it. A photon of light moving through that cubic mile of empty space without any molecules in it still goes from one end of that mile to the other end of the mile at 186,282 miles per second. That's pretty quick, but it's not infinite. Why isn't the speed of light through a cubic mile of empty space instantaneous? Why is there a delay in the photon getting from one end of this cubic mile to another end of the cubic mile? And there is a delay. And if you go back to what I said at the beginning of the show, and you travel through Celestia at the speed of light, you realize that the speed of light is actually pretty damn slow. In fact, it's remarkably slow when you get to the large scale things. From here to the nearest star is 4.5 years, and that's as fast as things move in this universe. Think about it the other way. We're so used to thinking of the speed of light as being instantaneous. We'll have it for you at the speed of light. Transmission to a GPS, it's the speed of light. It's downloading at the speed of light. Oh my God, that's so fast. It's not fast. I know it sounds like ether theory, Mr. Subtle, but the ether theory was onto something, because now I'm kind of just speculating here, but been around here for a while. What you're really saying is this: if something if the fastest thing in the object, the fastest known object in the universe, and not just photons, virtually everything that's information travels at the speed of light. Heat, light, cosmic rays, X-rays, everything travel at the speed of light. Electromagnetic radiation travels at the speed of light, and the speed of light to us seems very, very, very quick. Then, actually, I maybe got this backwards. Maybe it's compressed in the area of a mass. That makes more sense. I'm not sure. In any event, figure this out. It should be able to cross emptiness instantly, but it doesn't. It takes time. It has to push through something, and it's pushing through the matrix of four-dimensional space-time. Now, gravity is the observable effects of gravity are the result of masses moving through space-time. And that one way to think about these, there are talk of gravity manifolds, areas of low gravity, areas of high gravity, and there's a theory where you can start sending stuff through the solar system very slowly, but with essentially zero energy just by surfing these gravity manifolds and so on. There really is. I'm quite convinced that gravity is manifested as changes in density in space-time. And I'm not sure whether it's more compressed or less compressed, because I'm frankly not that smart. But what does seem obvious is that mass appears to affect the density of space-time and affect it in predictable ways, including the inverse square law, which is one of the great constants of the universe. And that if you understand this idea that space-time, that empty space can become more dense or less dense, then you get into some really cool kind of things, which I've been thinking about for my entire life, and that's the idea of a drive. You know, they talk about warp drive being something that produces a layer of like low-density space-time in front of you and high-density space-time behind you, and if you look at the diagram, it's like there's a high kind of a bubble in back of the ship and a low bubble in front of the ship, and the ship kind of runs downhill. That's that rubber sheet analogy. But basically, one way to think of it is if you could make space-time denser behind you and less dense in front of you, then the ship wouldn't need any kind of rocket reaction at all. It would be pushed by the dense space-time behind it and pulled by the less dense space-time in front of it, and the ship would move automatically from point A to point B in the direction of less dense space-time, pushed by more dense space-time, and there would be it'd be a reactionless drive. You would essentially create a gravity drive, because gravity strikes me as what this is. Now look, I don't live out here. This is not my job. This is stuff that's just become obvious to me thinking about it. But there are people out there that are dealing with this kind of thing. And if you really want to get to the top of the chain, really, I've mentioned this guy many times. Look, by the way, the reason I think there's something to this is very simple. When we take light, we think the speed of light is constant. We always talk about the speed of light in a vacuum, because light slows down when it enters the water and speeds up when it enters the air, and presumably speeds up again when it leaves the air and enters the vacuum of space, although the density is so much lower it's not noticeable as much. The whole reason we have refraction, the reason that light appears to be bent when it's in the water, is because light is slowing down as it enters the water and speeding up as it comes out. It just picks up speed. It doesn't get a boost. It's not hooked up to a turbocharger. It doesn't get an external kick. It's just pushing through water is harder than pushing through air, and pushing through air is harder than pushing through space, and pushing through space, empty space, is still pushing through the matrix. If you could lower, because all this stuff starts to make sense, if you could lower the density of space-time in front of a vehicle, not only would you be pulled towards it, but the speed of light would increase. That's kind of what I'm trying to say. And this, look, there must be 100,000 people who've had this thought ahead of me. I'm just telling you this is something I came up on my own. I'm not trying to claim I invented it. It just occurred to me that if you could make space-time in front of your vehicle less dense, you would never have to exceed the speed of light and deal with all the time zero stuff, because if you made space-time ahead of you less dense, the speed of light would increase. Light would move faster. It would have to, because it wouldn't have to push as hard through this matrix. And I think this is the answer. I mean, I don't know how to do it, but it strikes me as an engineering problem. At least some kind of an engineering problem. Seems like you send enough energy someplace, you might be able to have some effect on this kind of thing. I don't know. But it's consistent, and it's a different way of seeing things as the rubber sheet. And I now think of space not in two-dimensional direction with a third-dimensional depression, the rubber sheet with a bowling ball in it. I now look at space-time as a three-dimensional matrix through which we travel, where there are areas of high density and low density that pull or push mass on a trajectory, and that's what gravity is. And if mass can distort space-time, then maybe there's a way to do it with energy. Anyway. It's 8 o'clock. It's time to go.